Hello, now in this video tutorial, I'm going to teach you how to do multiple correlation and linear regression using MS Excel. Okay, now here is a sample of multiple correlation. So we have 5 variables here, but of course when we correlate them, we're just correlating 2 variables, but 5 variables are given here correlating among 2 variables. Okay, now Onyok wants to know among what type of sense of humor has a relationship with intelligence. Now we compute for the correlation using data analysis. We will be creating a scatter plot and then we will be interpreting the data. Okay, so it's a long. Now if you will be doing it manually, it will really take you years to finish or hours to finish, no? Okay, so again, we go to data analysis. We look for correlation and we make sure that the input range is empty, and we will be highlighting all the samples here. Okay, and then don't forget to check labels in first row as we included the labels. And then I think I want the output or the results here. Okay, and then we click OK. Okay, that's too fast, right? Okay, and then we adjust the... Okay, so we adjust. So let us analyze this one by one. Okay. Now, you see the relationship here. Of course, this will be 1 because if you correlate it by itself, the variable itself, it will always be 1. Which is higher correlation. I think that aggressive humor has a relationship, a weak relationship for affiliative and IQ. Also with the self-enhancing, no correlations, low correlations. This one is also related or has a correlation, and this one has a moderate one. So I think it's the aggressive humor. So as the aggressive humor increases, the IQ decreases. So hypothetically or based on the data, and as the self-enhancing humor increases, the affiliative humor also increases, but it's kind of weak correlation. This is a moderate one, 30. This is also a moderate one, and this is weak to moderate. Okay, now we want to plot it in a scatter plot or a scatter graph. Let's see. I think there are there's actually no relationship or very low relationship here, but look at it when it's being plotted. Now we highlight this first. We highlight them all, and then look at this. See, so it's not a linear one. Now maybe we can try to plot this. Let's undo it. Control Z. Okay. Maybe we want to try this one. The aggressive and the IQ. So let's highlight them. So IQ scores and so we highlight IQ and then we click control so that we can also highlight the aggressive. Again, so we highlight IQ and then you control, so you can highlight the IQ and aggressive, and then we go to insert and then scatter plot, and then see, it could be negative, but you see there it's going down, right? So it's a negative correlation, as you can see, but it's not highly strong. So there are some scores that are scattered here. Okay, so there you go. So that's how you compute and using scatter plot in the correlation or multiple correlation. Let's now proceed to linear regression. Okay. Now, here's an example. So you measure how much people are initially attracted to a person of the opposite sex and how anxious they become during their first date. So we have an example here. So attraction and anxiety. So you think if there's an attraction, if there's an increase in attraction, could there be also an increase in anxiety? So we will be computing the correlation. We will plot using a scatter graph, and then we will compute using the linear equation. And what anxiety score do you predict for a person who has an attraction score of 9? So let's say for example, so these are the data, and then you see a person has a score of 9. What could be the predicted score for anxiety? Okay, let's have the Pearson first. So again, equal sign Pearson, open parenthesis, and then we have the array 1, and then comma, and then highlight array 2, which is the y variable, and then close parenthesis, and then enter. So you got 0.81. It's a positive relationship, right? And then equal sign, then we have Corel function, Corel, and then this one, so this one, x variable, I'm just being excited, and then this one, and then close parenthesis, and then there you go. It's just the same. Now we go to data analysis function again. So correlation. So let's clear the box, and then we copy this all. Easier, right? It's easier to use the data analysis ToolPak, and then don't forget to put or to check labels in first row, and then I want the output range here because it's already templated here, and then click OK. Okay, it's just the same. So what will be your interpretation? So there is a strong positive relationship between attraction and anxiety on the first date. So as the attraction increases, the anxiety also increases. Okay, so there you have it, the interpretation. Now, how about for the linear regression? Now, it's difficult to compute for the linear regression manually, but it will be easier if we will be having a graph or a scatter plot. It will be easier to compute or to see the scores here. Now, we go to we highlight them first. So attraction and anxiety, we highlight them, and then we insert a scatter. Okay, so ito na lang. So this one, scatter plot. So see, it's almost a perfect or a perfect correlation because it's 0.80. Yeah, it's kind of close to. Now, if we want to compute for the linear regression equation, or if you want to get it, now let's have follow these steps. Number one, choose one data point. I choose this one. See? So once it becomes like that, you right click this one, and then you select add trend line. Okay, so when you select add trend line, you choose linear, and then you check display equation on the chart. There you go, the y-intercept, and display the r-squared value on the chart, which is the coefficient of determination. Okay, so let us analyze, and then click close. So let us analyze this. Now, if you want to get a score of, or what could be the attraction when you're at, what could be your anxiety score if you have an attraction score of 9? You see here the formula for the y or the y slope, and then there's an x there, right? Okay, now let us compute it. Maybe we can have it here. So, kung gusto nyo malaman what will be the anxiety score if you have attraction score of 9 based on the sample, so we just have to copy this. So, equal sign, and then you copy the 1.0531, and then the x, you have to substitute it, so by multiplying, so times 9 plus 4.1611. So what will be the result? So the score is 13. So if your attraction score is 9, probably you'll be having an anxiety score of 13.64. So there you go. So again, so you have to copy the y, or when you compute for the y, okay, so if you want to get a score, attraction score of 9, or what will be the attraction score for 9, so you just have to type equal sign, and then you copy the score, and then you multiply it by the x, which is 9, plus 4.1611. So there you go. So your attraction score will be 13.64, or 14 if it will be rounded to whole number. Now, the coefficient of determination is, we discussed last time that how much of the x variable is accounted to the y variable and vice versa. So that means that when you convert it into percentage, so 0.66 times 100, and then you'll be having 66%. So it's high. It means that 66% of your anxiety, or 66% of your attraction is accounted for the variance of your anxiety. So mataas, so 66%. So ibig sabihin 66% na may kinalaman yung attraction niyo to your anxiety. Okay? And there you go. So you have lots of examples here that you can follow through and that you can practice. And that's all for the multiple correlation, linear regression, scatter plot, and coefficient of determination.